Okay, sorry about the tank top, it's hot, but there are some things that I need to address for my students, and it's not something I can just cover in one class. So the topic of this video is going to be creating messages in Max. It's going to be a little abstract and divorced from actual practice, but as an overview of different ways that you can create a list in Max, that's what I'm going to be going over because there are so many. So first of all, we're going to start with the pack object. So if I say PACK, first of all, we have to know about Max's data types, but I'm not going to go into a deep discussion about that other than to say that if I want an integer, I would use a lowercase I. If I want floats, I would use an upper or lowercase f. But let's just stick with this integer for now. I'm going to create a couple number boxes just with the I key on my keyboard. And it's also out of the scope of this video, but also worth mentioning the difference between hot and cold inlets. So this cold inlet does not trigger the calculation. So I can set the value of the second inlet and, oops, this is not going to show us anything because we're making a list. So now I have something that can display a list. Now this inlet, if I hover over it, is red, so that means it's hot, and that means it triggers the output. So when I move this, we are going to get an updated output. When I move this one, I do not. And this is how the pack object works. Every inlet can be defined by the data type. So as I was saying earlier, let's add a float. So I use a lowercase f. I'm going to instantiate a float object with the F key on my keyboard, and when I move this, you can see the output has not updated, and it's only going to update when I trigger the first inlet, which is hot, and there is the resulting message with the floating point. Data type. So this is a list of 3 numbers. And I could continue to add different types of data types, like an S is a symbol, so I can add cow to the end. Oops. And now is a good time to mention that I'm using this message box in a very non-standard way. I'm using it to display a list. And the problem that we get into is because this inlet is the equivalent of using the set message in Max, which means that no matter what goes in this inlet, you're not going to actually get a triggered output from it. So you can't be expected to see the output as it goes down, because if I hover over this patch cable, there's no data there at all. So just beware that this is just for monitoring. If you want to take the output of the result of this message, then you have to take it from the original outlet. So this can be used with like the note in object. So if we wanted to see like pitch and velocity together. So let's say we have a note in object, and I'll set the port of this to my oxygen, and then we're going to pack together the pitch and velocity. So if I want to see this, another way of doing this real-time information is not to use the message box as I was doing here, but to use print. And print usually means that you have to have the Max console up to see the result. But you can keep this closed and then say, oops, I don't want to add a space at the beginning. Print at pop-up 1. And as you can see, that will display in a pop-up, so you don't have to have that side bar open in the Max Patcher, but that's actually more difficult to type than just hitting the M key on my keyboard. So that's the method that I typically use, but it's probably not really correct to do so. You're probably asking yourself, why is only the first inlet hot? And the reason this goes to Max's right to left ordering, and it is based on the assumption that the first inlet of any object triggers the calculation. And you don't want to trigger the calculation until all your variables have been set. And so you want to do that by filling in all the inlets to the right of the trigger inlet, which is going to be the leftmost inlet. All right, so now once we have a list, There are some objects that can receive lists, but you may not be aware of them. So like the add object. If you use an add object with no arguments, you can take a couple integers in here, and it will treat them as if you're setting both operands of the calculation. Actually, to this one, I can use a number box. So that would be the result of the calculation. It's a useful feature, I guess, but it also trips up beginners if you have an add object that's inadvertently getting a list. Like maybe you're not aware that somewhere upstream is generating a list, and you may get confusing results. Another way this can be used is with the note out object. You have a pitch and velocity inlet, but if you send a packed list into this, like I could say, middle C with a velocity of 64, that will start a note. This is not connected to anything, so we're not going to hear anything. And then if I wanted to turn that note off, pitch and velocity of 0 of that note would go into the note out. So there's lots of objects like this that may receive lists in a way that you weren't aware of. So that's why it always helps to use the hover over help. And actually, I just made a liar of myself. So to use the reference. So here you can see that if I'm using the note out object and it receives a list, yeah, it's not even notated here. So anyway, amnesia ray. Next up, this actually is a topic I should probably cover on the topic of what a packed list means. I think it's interesting, and I'm sure this is true for languages outside of Max, is that the number of elements in a list itself has meaning. And you can see this with like how the add object behaved, but there's also like a series of objects in Max that are designed to recall data. The simplest of this is funbuff, and funbuff has a syntax where if you send it a pair of numbers, like I could say 1 and 11, what it does is this is going to set the value 11 at index 1. If I wanted to do the same thing at index 2, and I want to send that, set that to a value of 22, I've done so, but we're not going to actually see anything until we send a different message to it. Now I can recall the data at that index. So if I send just a message that is one integer, in this case the index 1, it should return the value 11. If I were to do the same thing with 2, of course we're going to expect to see 22 come out of funbuff. This syntax also works on a couple more objects. So if we replaced funbuff with, we could use table. This is going to do the same thing, except that table also gives us a user interface to edit this stuff, but let's ignore that for the time being and just concentrate on the fact that if I set the value of these two indices, so the value of 11 at 1 and 22 at 2, when I recall value number 1, index 1, we should get value 11. This table and itable by extension, because it's basically the same object, uses exactly the same syntax. We can continue forward to the next object, which is the call object. Call allows you to use the same syntax to write data into the call. The difference is that we can now see the data in the call by double-clicking on it. And it's also worth mentioning now, I'm going to do another video on this, but there's call.codebox, which gives us this inline representation, which is really super nice. So these are different ways that you may start using packed lists in Max to store data or to make calculations. Let's see what's next on our list. Okay, so there's some English words that we use, prepend and append, and if you think about what those words mean, prepend means to put something before, and append means to put something after. There is a lot of managing of lists and symbols in Max, And prepend and append are some of the most commonly used, and the ones that you're also going to use in, well, prepend, I think you would also use that in Rainbow. So let's take a look. We're going to prepend bark. So what this is going to do is it's going to prepend the symbol or this word that we just typed, bark, into whatever comes in the input of the prepend. So I'm going to make a message box, and we're going to say we want dog. So because this is a prepend, the bark is going to come before the dog, and if I click this, now I have the result, which is bark dog, and this is one message that contains two elements. If you want to do the same thing on the end, we could use append. So now when I click this, it's not going to be bark dog, it's going to be dog bark. You can, with the argument that we're supplying to append can be overwritten. And this is something that is confusing for beginners in Max, because what we have here for the append object, it looks like no matter what's coming in, it's going to append bark to it. And that is what is in fact happening. Like I could say moo, and now it says moo bark. Now, I can now send a message that will change the behavior of this append object, but it's not going to update the word bark that we actually see in the object itself. And I'm going to do that with the set message. So the message set followed by the word that I want to change append to. We're going to change it to cow. Now if I send this message, nothing happens because the set message universally in Max does not trigger an output. But now if I take this moo message, the message should now be moo appended with cow, so moo cow. And there it is. You can use append to create longer lists. So for example, this is a long list, and we're going to set this to be a very list. So now I'm going to set that to be very list. This is a long list, very list. And now we get that. So that's prepend and append. And this should be some of the first objects that you learn about when you're creating messages. Now, one thing you're probably thinking of is like, why is there only one hot inlet? And there can be multiple hot inlets. That's why you always have to hover over the inlets to see whether they're red, meaning hot, or blue, meaning cold. Let's say you're in a situation where you need to create a message where it is triggered by the second inlet. So for this, we're going to use POC. I'm pronouncing it POC to differentiate it from PAC. PAC operates the same way, POC operates the same way as PAC, in that I'm going to initialize it with a couple arguments, in this case looking for integers. And it is going to send immediately when I update the second inlet. You can see when I hover over this, the inlet is hot, it's red. So I've initialized this as two integers. When I move it, this I is going to be replaced by a 0 because it hasn't been changed by some input that's coming into the object. What I can also do is I could set the default here. I could say POC and say like cutoff. Like maybe I need to make a message where I need to send the message cutoff into a synthesizer or something I've made. And this is the value of cutoff. This is going to be functionally equivalent to just saying prepend cutoff. So this is going to generate the same exact message. You can set these values. You can initialize these values with whatever you want. So I could have an integer and a floating point number, and now whenever I send this message, it's going to send those values. Now, this is nice if you need to initialize the values, but sometimes you don't want to do either. You don't want to define the data type, and you don't want to have all inlets hot because that may lead to buggy results. So there's a very specific situation where you want to define how many inlets you have and define which inlets are going to trigger the resulting message. So that's where the join message comes in. If you use join without any arguments, it functions pretty much like the pack object. So if I join two integers together without any arguments, that would be the same as pack without any arguments. But you can do other things, like you could say join, I want to have 4 inlets, and I want to have just the second inlet to be hot. So I would say at triggers, the inlets are numbered from 0 in this case, so unfortunately the second inlet is going to be triggers 1. So now I've got 4 inlets, and you can see this is cold, this is cold, this is cold, this is the first inlet. Join at triggers, sorry, that's why that didn't work. Okay, now this is cold, this is red, and this is cold, and this is cold. So nothing's going to happen when I move this first inlet, and now when I move this one, we can see that the result is triggered. You can have any combination of these inlets be hot. So if I wanted the second and fourth outlet, I would say 1 and 3. And so now you can see that this is hot, this is cold, this is hot, this is cold. Bam. And you'll note that when I changed that argument, all the values that were previously there got replaced with their default values. That's because I didn't just change the argument. What happened was a new object was instantiated in its place. And so in doing that, I reverted the object to its default state, which is why we got all those zeros there. But that's nice to understand. Also, it's worth mentioning that sometimes when I'm checking my students' work and I go around the room and they have everything exactly right, but the patch doesn't work as what I've done, sometimes what happens is the object is in a state that they don't know is malformed. So like an object can receive a message upstream, and you can't really see the internal state of that object, or there's no easy way for you to understand that some argument was set and that object maybe got deleted even. It doesn't matter, that message went down to that object. And so a simple fix is just to delete the object that is suspect and then hit undo, and it will revert it back to its original state. Okay. Let's move on to ways of storing an integer and a float. Ways of storing values. Let's just do that. Okay, so if I want to store an integer, if I want to store an integer, I can use the I object, which is short for int. These are functionally equivalent. They're the same. I always use I because it's much shorter. And what this allows me to do is I can set a value and I can send it out at a time of my choosing. So there's the value I set, the value is 44, and now if I bang it, then I get 44 down there. If you want to store a float, you can use the float object. Like the int object, I never type out float, I just use f. And so now I can do the same thing, where I can store this value and then send it out at a time of my choosing. Now, if I want to store a list, what you're going to use is the list.reg object. Now, there's another name for this object, like all list.objects. They used to be called ZL. So ZL.reg is functionally equivalent, ZL.reg is functionally equivalent, and list. I don't think I can get away with this reg. I've never tried it. And oh, that works too. So these are all the same object, but then they all do the same thing, which is store a list. So let's make a list cow moo. And if I throw this in here, and that's so we can see the output, and a bang will trigger it. And did I set it? Bam. Okay. So those are the 3 methods. If you want to store an integer, if you want to store a float, if you want to store a list. If you want to truncate a float, you can do that a couple different ways. Also, in Max, there's probably no fewer than 4 ways to do any given thing. So if you see something I've done that contradicts something you've seen earlier, maybe they're the same thing, but I'll try to cover a couple of them. One way you can truncate is you can you can use just an int object to pass anything through. So this is going to, like I said, it's going to truncate to the, it's going to round down. You can use an int object and pass that through, and that should also give us an int. You can use trunc. Oops. Oh, I wonder if I don't even think there is a message version of trunc. There isn't. You can use round, and this is going to give you more control. We want to round to the nearest integer, and we want to round to nearest. So I could say at nearest value, I'm going to turn that on. And so now when we are below 0.5, then it's going to give us the lower integer, and when we're above 0.5, it's going to give us the integer above that. And okay, good, covered that. Okay, how many times has this happened to you? You're looking at some max patch that uses a function object. One of my favorite objects, I love it. Function, not funbuff. Function. All right, so by default, it gives you a time domain of 1,000 milliseconds. You can change that time domain, and actually there's a couple conflicting messages which are worth knowing about because they're kind of confusing. But let's just focus on crafting the message to change the domain. So I'm going to enter in some type of function, and the message that we need to do in order to control this is to prepend the message domain, because we're going to change the domain to a value of our choosing. So I prepend domain, and let's make I'm going to use a live dial for this, and we're going to choose a prototype of time. Oh wow, didn't seem to inherit. Oh, maybe it's set all those, yeah, all those. It seems to be they're using dynamic colors. I'm not sure why it looks so weird though. Okay, so as I move this, let's take a look at the value that's coming out here. I want to see exactly. Okay, so this is how many milliseconds we're setting our domain to. And the reason we're saying prepend domain is because we want to change what we can see, and that means that it's going to scale the contents. So if I made this a little bit, if I made this a little bit smaller, when I zoom this in, then it's going to appear to grow. Now, I'm going to add an adder UI that's going to show me the domain. Let's see. And so now you can see I'm changing the domain here. Now, if I say set domain, this is going to change the domain without scaling the contents. And there's no visual indication of what's actually going on. If you're looking at the function itself, it's like, I'm using set domain, but it doesn't seem to be doing anything. The domain is actually changing here. So that's the difference between set domain and domain. When you change domain, you're scaling the contents, and when you use set domain, you're not scaling the contents, you're just changing the domain of the window. So let's do the same message several different ways. So here's the prepend method. This would be functionally equivalent, where I use tokens. So I'm going to say domain followed by $1, and I'll explain what that means in a moment. So now when I move this, you can see domain $1. And what the resulting message is that with that number. So these messages are identical, right? One more way to do this, as you probably kind of figured out before, is you could use the POC object. POC, domain, and then whatever this float's coming in. I'm going to borrow this user interface object. So the resulting message should be the same. So if I plug it in, it does what we're expecting. So this is another way of actually using, there's 3 different methods of actually showing how you can control a very common parameter. This technique can be deployed to lots of different max objects. we covered join. Okay, sometimes you you encounter a message box in Max, and this especially happens with the line object, where you have a number and then followed by a comma and then something else. And so I'm going to make a line tilde just to demonstrate. And because this is outputting a signal, I'm going to use a number tilde. Okay, so what this means is, well, let me back up because I can't assume that you're going to, that you've done this. If you send to the Max console, hello, comma, world, which is typically the first thing you do with a programming language. When I go to the Max console, I get hello, and then on another line I get world, and the comma disappears. That's because in Max, the comma means something special, and that means that you're going to break up this message into multiple messages. And so this goes back to what I was talking about, where the number of elements in a message itself has meaning. If the line tilde object receives a single number, it's going to go to that value immediately. So the message 0 with no other elements in the message are just going to go to 0. If I send it a message that contains multiple elements, in this case, if I want to go to 1 in 1,000 milliseconds, it's going to interpret this message differently. So now it takes 1,000 milliseconds to get to the value 1. So what this message actually means, 0 by itself means start at 0. No matter where you are, you're going to start at 0. So, and then it sends another message. It's going to go to the value 100 in 1,000 milliseconds. So it's at 1 now. When I click this, it should go to a 0 immediately, and then it should, from there, go to 100 in 1,000 milliseconds. So a message box can contain multiple messages, and that means I could break up multiple lists. So if I said cow moo, comma, dog bark, dog bark, then I should get on 2 lines in the Max console, cow moo and then dog bark. Oftentimes we encounter something where we have to use the ZL object, and as I mentioned, the ZL object can be used in a different, or it can be named something else, and we're going to use list.reg to do this. The reason it was ZL is because it was an object that incorporated a lot of functions from Lisp, and anytime you want to manipulate a list, you want to use these functions. So go to the help file for list.reg. Let's just see what happens when I open this. I'm going to let's open the objects overview. And most Max objects are not like this, where their argument kind of changes the function of the object very radically. But ZL has lots of different variations that do many, many different things. Some of the most common ones that you're going to find, like ZLreg is the one that we used earlier, or list.reg. And list.group is something that I use quite a lot. So let's just see how this operates. So I'm going to instantiate a list.group, and I'm going to give it an argument of 4. Now I'm going to create a slider and just generate a bunch of data. And what it's going to do is it's going to receive this and spit it out whenever it receives a buffer of 3 elements. And if I move really rapidly, I might get like some some changing values. But you can see how this could potentially be useful. It creates a list from an input that's coming in real time. You can have list.group work on an arbitrary number of items. So if I had this slider plugged in and I move it, then I can send the list later at a time of my choosing by hitting the bang, and then it will send that entire thing all at once. So that's great if you have if you have an arbitrary number of items, you don't know how big the list is going to be, which is something that you do need to know if you use pack or poc or join. You can take a list and then use a function in the list family like list.sort, and this will give me a sorted list of the input. So these should be in numerical order. Maybe you've got this and it's like, hey, I wonder if there's some duplicate values. You could say list.thin, and you could get rid of all the duplicate values. So you hopefully end up with a smaller list. I wonder if this actually did anything. You can tell by the size that's definitely the case, but if you want to know how many elements in the list, you could say list.len. And that's going to output a number of how many elements are in the list. Boop. Okay. One of my favorites, especially in the sequencing, like this, let's say this is my list that I have. You can get a particular element of the list. So I could say list dot, let's use mth. No, let's use nth. Mth is nth just starting at 0. So if I want to get an element of the list, I'll use trigger here because I want to do two things. The first thing I want to do is I want to send the list I want to process into the list object, and then I want to send, I'm sorry, I got that backwards. The first thing I want to do is I want to send the rotation value, or the element that I want to retrieve, into the right inlet. And in the left inlet, I want to put in the list I want to process. So when I use my trigger object, the first thing it's going to do, it's going to pass this argument down. So it's going to say, this is the number, right? And so now give me the 18th value in the list that you're going to process. And the list that we're going to process is going to be fed to it from this bang. This is the second thing that happens because it's right to left ordering. And then this should get me whatever integer is at that position. If you want to rotate the entire list, you could use list.rot. And that has many musical applications. Okay, let's talk about route. Okay. The route object. Wow, can't type. Maybe fingers aren't on the right place. This is, you know what? Before I talk about the route object, I promised I would talk about something that I then skipped over and then didn't talk about at all. So that would be list tokens. So let's talk about route in just a moment. Let's shelve this conversation. I did this thing earlier when we were doing the function object. I said $1, and then I didn't explain it anymore. This is how tokens work in Max. So if I have a list, cow, dog, duck, and then we have moo, bark, and quack. Now, each element of the list here, we could say this is the first element, this is the second element, third, fourth, fifth, and so on. We can manipulate these elements of the list. So I could say, if I just wanted the first element of something, I could say, give me the first element with token 1. And now if we view the result of that, that should give me cow. If I want to know what a cow says, then I could say I want the first element and the fourth element, and that gives me cow moo. If I wanted the second element and fifth element, I could do that, and so on. So you have tokens 1 through 9, and then if you need more strong medicine than that, then you can use like other tools like the list objects. So another example of the list object that's useful is using slice. So if I wanted to, just give me the first 4 elements of a list, I could do that. And then the cool thing about that is it gives me also the remaining end of the list. So you can choose these slice points and then process that portion of the list. Now we can talk about the route object. So route, cow, dog, and duck. Now I'm going to arrange my lists a little bit differently here. Like, let's say I wanted to pass the appropriate message to the appropriate outlet. So each one of these outlets corresponds to an argument that I've added here. So cow, dog, and duck, if I hover over it, if the input matches cow, then it's going to come out of that output. So we could say cow, moo, and then maybe even some additional information, like what do cows like? They like grass a lot, and they're happy when they get let out in spring, first thing when they've been cooped up in the barn. So if I click this, what route is going to do is it's going to look for the first element of the list. In this case, the first element of this list is cow. It's going to strip off that first element. You don't need it anymore. If you do, there's an alternate object called route pass, but honestly, route is the one that is the most useful. It's going to pass the rest of the list. So cow, moo, grass gets passed out of that outlet. Meanwhile, these other outlets don't do anything. I could say dog, bark, and now when I click this, we should get bark from the cow outlet. And maybe we need to expand this later. Everything that does not match then will be passed to the last outlet. So we're going to route chicken. And we can see that if I pass chicken and we'll say bok in here, and now we get chicken bok. Now, this is different from the other outlets, that when they're matched, then they stripped off the first element that they were matching. Here, it didn't strip off the first element because it's not useful if it does do that, because this is just the input if the input doesn't match. What this allows you to do is pass it to another route object, which you can then chain off of. So now that you know about it, you can make use of it. All right, let's see. Okay, so the math objects, the normal math objects in Max are pretty simple, for doing simple arithmetic that involves two elements, but obviously math gets a lot more complicated than that. I'm going to show you a functionally equivalent version of this object that adds two numbers together. If I wanted to add floating point numbers, you have to initialize these with a floating point value. Otherwise, you'll get an integer output. So just remember, even if it's 0 for add or 1 for divide. So this is going to be functionally equivalent to this object. I can use regular C expressions and say I define the inputs with number 1 input's going to be a float, so I want to add that to the second input, like so. And then I can set this value. I could set this value, so now it will add those two numbers together. So if you can formulate your expression in the form of a regular C expression, then you can use the expr object for that. This is a nice step to then performing math on lists, which happens also all the time. So let's say you have two lists. We've got 11.1 and 22.2, well, 22.2. Okay, so that's going to go in this inlet, and then we want to add that to this list, 33, oops, I keep hitting the wrong key, 0.3 and 44.4. Okay, so expr only works on, does not work on lists, but I can change this to vexpr, and now I can set the second inlet, and we need to replace this with a list or a message box so we can see the list, and then it will add these two numbers together to these two numbers together. Sometimes you want to scale a list of numbers, and so like you're going to multiply one value or a set of values by a scalar value. And this is kind of annoying because, actually I'm going to do this the other way. Let's say this is the value we want to scale, and this is the amount we want to scale it by. God, I just did that wrong again. So let's move that back over. So this is the list we're going to process. This is the amount we're going to scale it by. And we're going to set, if we want to do this, I don't want to, like, if I want to scale this entire list of numbers, I don't want to do the situation where I have to create a list of numbers that matches the number of elements in the first. So if you want to do that, you can turn on at scalar mode. And now when I bring this in, I'm going to force this calculation to happen. Like so. It would be more appropriate to use a trigger object here. Trigger float, sorry, bang float. This will bang the list to be processed, and this will pass the float down. And if this list got bigger, if it were like 55, 22, 22, then it gets bigger. This technique is typically done with like where you're storing the list. I don't really like to store lists inside of a message box, so I usually use like a list.reg to do this for me. And then I will set the value of this reg here. This gets banged and sent out. So I set the value and then it just bangs that list.reg object. Okay. I think we're reaching the end. We're almost there. Okay. Sometimes you want to format messages without spaces. And for this, instead of using join or pack or whatever, because that's going to make a list, it's not going to make one message. So a good example of this is like a path on your computer. If you need to put together that path, you're going to use the combine object. I'm just going to open up the help file here because I don't want to spend time creating an example, but it works like the join object in terms of the triggers attribute, which you can see here in the help file. But the way it operates is you have all these arguments that define like one portion of this gigantic string of characters that you're putting together. And then when I bang the output, it's going to join it all together without spaces. And before the combine object, I'm sure you had to do a lot of work with like regex or objects like that. So now thankfully we don't have to, and we've got the combine object. Okay, one last thing I want to mention is creating lists of lists, and this is less of an issue now that we have kind of better dict and array support in Max, but sometimes it's unavoidable, or you're using the call object where you need to have like 3 lists of 3 sets of numbers. So what you would do with that is use literals in Max by encapsulating them in quotes. So I would say 11, 22, 33, that's one list. And then the next one would be, let's see, 33, 44, 55. And then another group of 3 that is 66, 77, and 88. So if I were to take this message and put it into a list.len, the number of elements should be the number of elements that are encased in quotes here. So it says there's 3 elements in the list. If I unpack, I would probably just use an unjoin instead of using like unpack symbol here. But if I say unjoin and then just say I have 3 elements that I need to unjoin, it should give me those from each one of these outlets. And they're still in these quotes. So I can't unpack this further. In this situation, what you can do is there's an object that will remove and add quotes to make things symbol or make things not symbols, and they're called toSymbol and fromSymbol. So since we want to turn a symbol into a list, we're going to use fromSymbol. This is going to strip off the quotes and give me a list of 3 numbers. And you can see that if we use our list len here, list will give me 3 elements. And if I wanted to take this and turn it into a symbol, then I would use toSymbol. And so that is a way of allowing me to have lists inside of lists. I think that's it. That's everything. So, okay, I'm sorry. I lied. There's one more technique I want to show you. And this is very common musically, where you have a MIDI controller and you want to grab like a chord that you just pressed. So I'm going to demonstrate this by using note in, and I'm only interested in my downward key presses. I'm not interested in the velocities, nor am I interested in what happens to my note off messages. So I'm going to use a strip note. And this is going to give me just the pitch of the downward key presses on my keyboard. Now, this is giving me the real-time information, but when I press like multiple keys, it's just showing me the last key that I pressed. And what I want is when I press a key, like a chord, I want to get all those numbers that represent that chord. So for this, what I use is quick thresh. Quick thresh. And I don't need any arguments here. And what quick thresh is going to do is it's going to collect all all integers that are collected within a certain amount of time. And I think the default is 100 milliseconds. So if I play a chord, it's just going to give me the 4 notes that I just played on my keyboard. And that is quite useful. Oh, no, it's not everything. One more example. This happens quite a lot, where you have a list of numbers, usually with like a multi-slider. Let's make a multi-slider, and I'm going to give myself just like let's say we've got 64 sliders, and the range is going from 0 to 127. And we also want to age compatibility, draw sliders. I guess we might have lost an option, but it doesn't matter. Anyway, so I've got my 64 sliders. It's going to generate a list. Bam. Right? Okay, so a lot of times, especially if you're like feeding like a poke, or sorry, using a peak in order to write a waveform, you need to, well, let's just do that. So let's change this. Instead of like integers, it's going to go from -1 to 1. And let's say we're like designing a waveform, kind of like that. And we want to set this into a buffer. So let's make our buffer, we'll call this waveform. And we're going to set the size of this waveform with the size and samps message. Size and samps, we want 64 values, so I'll say size and samps 64. Bam. And now I'm going to set that with this user interface object. So we're going to use the peak object to write into I think I called it waveform. Dang it. And the inlets here are the sample index and the value that you're writing into it. And you'll note that this is hot. Well, they're both hot. I'm going to use a list funnel. And what list funnel does is, this is one list of 64 values. List funnel is going to give me 64 lists of 2 values. And they're going to be of the format where the index is appended to the beginning. So you can see that for my, let's do this once. 63 all the way down to 0. Right? It just appends this integer, which is the index of the value, followed by the value. Well, it turns out that this is exactly what peak is looking for, the sample index and the sample value. So I unpack integer float and throw this in here. Blam. Now let's take a look at our peak, and there we've written it into our buffer. Okay, I think that's it.